let's learn about hemolytic activity. The hemolytic, referring to hemolysis or destructions of red blood cell, which leads to the release of hemoglobin from within the red blood cell into the blood plasma. So remember, every time you hear about the words hemolytic, it means that the red blood cells actually burst and release the hemoglobin inside of the red blood cells. And then, in simple words, hemolysis is destruction of the red blood cells. Hemolytic activity is useful in classifications of Streptococcus species because some Streptococcus species produces hemolysin, a substance that causes hemolysis. There are three types of hemolysis: the beta hemolysis, alpha hemolysis, and also non-hemolytic, or also known as gamma hemolysis. Okay. Okay, now let's learn about beta hemolysis. Beta hemolysis Streptococcus give the discolorations of yellow. So hence the yellow in the subtitle here. Okay, because when we grow the beta hemolysis Streptococcus, example here Streptococcus pyogen and Streptococcus agalactiae, it will give the yellow color to the colonies. Okay, I'll show you the figure later. Usually several millimeter in diameter and caused by lysis of red blood cells in the agar medium induced by bacteria hemolysin. So remember, the bacteria that is beta hemolytic Streptococcus, it contains the hemolysin. Okay. Commensal Streptococcus are often called viridin Streptococcus, which refer to their alpha hemolytic property, where viridin means green. Okay, that's for the alpha. And then you can see here. So that usually, let's look at beta hemolysin. Okay, just now, whenever we grow the Streptococcus beta hemolytic bacteria, it will actually, we will actually grow it on blood agar. Okay, so that this is the blood agar, and then you can see it clearly. This is the colony. Remember when I told you, if we grow, we will do the streaking method, and then this is actually the bacteria, and then you can see that over a certain diameter of the colonies, it's actually cause it turn the blood agar into yellow or a discoloration of it. Okay, it is also clear here as well. Look, it is a few diameter discoloration not only at the colonies here, but then a few diameter of the colony as well. So this is beta hemolysis. Okay, and then for alpha hemolysis, it will give rise to a green discoloration. Oh, sorry. Look at here. This is alpha, okay, or this one. It give green to this. It gives green discoloration around colonies on blood agar. These usually occur in most commensal Streptococcus. This phenomenon is termed as alpha hemolysis, although not caused by hemolysis. The factor causing the green discoloration is hydrogen peroxide, which oxidizes hemoglobin to the green metahemoglobin. Okay, so that it doesn't have hemolysin, but then it turns the colonies to green due to the hydrogen peroxide. Okay. Now, so that's alpha, okay. It stated here is cause green discoloration not because hemolysis activity but hydrogen peroxide like oxidized hemoglobin, okay. So that for non-hemolytic, um, so that for the organism that does not induce hemolysis, the agar under and around the colony is unchanged. So that here is the color. So you can see clearly here the yellow color up here. The yellow color here is actually the color of the colony, but then not the discoloration of the blood agar. Okay, nampak tak kat sini is very clear that this is actually the bacteria colony, but not but nothing happened to the blood agar. No discoloration to the blood agar. Okay, that's what we call as non-hemolytic, or also said to display gamma hemolysis. Okay, so that if it is called gamma hemolysis, it means that there are no hemolysis here. Nothing happened to the blood agar. Enterococcus facialis, Staphylococcus saprophyticus, and Staphylococcus epidermidis display gamma hemolysis. Okay. So I've told you here. So that this is beta, give the yellow coloring, alpha hemolysis, give the green coloring to the blood agar, but then for gamma hemolysis, nothing happened. Okay, it is very clear here. And then now here is the summary of the classifications of hemolytic activity based on the clinical importance that we have discussed just now. Okay,